Welcome everyone. Today, I'm excited to present to you the advanced ACO push system. I designed it with a strong focus on ease of use and flexibility, allowing you to integrate it into any game with whatever settings you need. In this video, I'll walk you through all of its features and explain exactly how to use it. So, what makes the system stand out from the rest? Firstly, ease of use. Once you copy the files into your project, it only takes a few simple steps, less than 2 minutes to get it up and running. Secondly, the highly customizable. It can be adapted to fit any gameplay environment in many different ways. For example, fully compatible with both first-person and third-person games, or even both at once. I'll explain this in detail later in the video. You can freely assign and customize any animations. You also get full control over movement variables for advanced animation customization, or for calling the animation from any other blueprint. And each pushable actor can be uniquely configured with its own settings. It also includes full audio customization with 3 optional sound triggers. When pushing starts, on each collision, while pushing. Also included camera limit system. The system supports both first and third-person perspectives. You can choose to restrict the player's camera movement while pushing, or leave it free. You can also fully control the camera limits and adjust them however you like. Collision and angle detection. This system is designed to prevent unnatural overlaps while moving or rotating objects, giving a much more realistic and polished feel during interactions. Automatic stop conditions. Pushing will stop automatically if the player falls, or if the object being pushed falls. Multiple push modes. Push objects in various directions. Forward, backward only, side to side, rotation only, or even from a fixed point. You can mix and match push styles freely, depending on your gameplay needs. Finally, the system includes demo to test it and an example project that demonstrates every feature, along with complete documentation for quick reference. And if you need any help, Discord support is available. We'll dive into all of these features and more in this video, so stay tuned. After you add the push system to your library, all you have to do is add it to your project. Just go to the Unreal Engine section in the Epic Games launcher, search for ACO push system, and then click Add to Project. Once that's done, open up your project and you'll find a folder that looks like this. You're free to explore it, but let me give you a quick overview. Inside the ACO Push Sys folder, you'll find a folder called Blueprints Base. This is where all the essential blueprints are located. These are the ones that make the push system work. There's also a folder called Example Content Demo. This contains all the assets and actors used in the example demo. Feel free to check them out and see how things are set up. And finally, you'll find a folder named Input Push. This is where all the input mappings for the push system are stored. You can customize the input keys however you like, or even add your own inputs to extend the system. Alright, now let's move on to setting things up. First, go to your character and add the BP ACO push to your character. Then do the following. Get the function try find closed AC push from the component and connect it to your push input action. In this case, I will use the F key. After that, from the AKO push component, get the function check push object M2 and connect it to the event tick. Next, grab the function camera axis from AKO push component and hook it up to your IA look input. While you're at it, also get the variable camera limit in push. You'll need that to control camera limits during pushing. Then get the function getMoveValue from AKO push component and connect it to the IAMove input. And finally, in the begin play event, make sure to use add mapping context and assign the push imperator to it. And with those simple steps, we've finished setting up the system. But before we move on to testing it out, there's one last thing we need to do. We need to add new object channels. So here's what you do. Go to Project Settings, then Collision, then Object Channels. Click New Object Channel. Name the first one Push, then create a second one and name it Unable Push. Set the default response to block for both. Before we wrap things up, there are two small mistakes I made earlier, so let's go ahead and fix them now. First, go back to your character, and in the IAMove input section, right after the press is completed, add the getMoveValue node again, but this time leave its values empty. This is important to reset the movement correctly. Second, go to the branch connected to camera limit in push. We're going to change it so it flows through the false output instead. That's it. Just those quick changes and everything will work as expected. Once you've done all that, you're ready to start using the push system however you like. Just make sure of two important things for any object you want to push. Avoid using complex collision. The system requires simple collision for the physics to behave correctly. And make sure the pivot point of the static mesh is centered. This is key to making everything work smoothly. Now you can simply drag the actor into your level and start using it right away. As you can see, the pushing works just fine, but we still need to add a push animation for the character. Also, you might notice an error showing up. That's simply because we haven't assigned a push sound yet, and we'll fix that right now. Go to your character and click on the Akko push component, then scroll down to push sound. Here, you can either assign any sound you like, or just use the default sound that comes with the system. Alright, now let's move on to setting up the character's push animation. First, we're going to create a new blend space for the push animation. You can use any animation you like or just use the ones that come with the system. You'll find them in the animation section inside the example content demo folder, or you can just search for them directly. Before we start adding animations to the blend space, let's set up the axes. For the vertical axis, rename it to forward backward and set the range from -1 to 1. For the horizontal axis, rename it to right left, also from -1 to 1. Now set the smoothing time for both axes to 0.5, so the transitions between animations are smooth and natural. Alright, now it's time to place the animations. At -1 on each axis, you'll place the backward or left movement animations, and at 1, you'll place the forward and right movement animations. Once you're done with that, it's time to move on to the animation blueprint for your character. Here, we'll start by bringing in all the variables related to the push animations. First, use getComponentByClass to retrieve the Akko push component. Make sure the class is set to Akko push component. From that component reference, you'll need to extract the following values: forward, backward, right, left use. Push is turn, left is turn, right, stop turn. Once you've got all of those set up, we're ready to jump straight into the anim graph.
Inside the anim graph, we'll start by creating a new state and name it /backward. We're going to connect it to the idle state. On the arrow going from idle to forward or chahan backward, we'll add the condition use push. On the arrow going back from forward or chahan backward to idle, use not use push by connecting it to a not boolean node. Now, inside the forward or chahan backward state, add the blend space we created earlier and plug in the forward backward and right left values we got from the component. Next, create two more states, one called push idle and the other called push. Turn connect push idle to the forward chart backward state, and inside it, place the push idle animation. You'll find this animation in the set that comes with the system. As for the transition arrows between these states, just follow the same setup shown in the video for the conditions. Now for the push turn state, connect it accordingly, and again, follow the same transitions and conditions as in the video. And with that, we're done. Let's go ahead and test it out. Looks like there are a few small issues. That's probably because I forgot to adjust a couple of things. So let's go ahead and fix them real quick. And there we go. Everything is working perfectly now. As for the small overlap between the character and the actor, that's totally normal, and I'll show you how to adjust that easily in a later section. So don't worry, it's a quick fix. From here, I will explain the settings and customizations that you can modify through the actor and the character. Let's begin with the actor settings. First, you'll find trace tall, which determines the reach of the arrows. This in turn sets how close or far the character needs to be before the pushing action begins. You'll also see height arrow, which controls the vertical position of the arrows. In most cases, you won't need to change this value, as the character should usually start pushing while standing on the ground. Additionally, you won't be able to modify this setting unless you set Enable Auto Agi to false. As for Enable Auto Ag, its function is to automatically keep the arrows aligned with the ground. If you set it to false, you'll notice the arrows can now rise above or sink below the ground level. Regarding select axes, it's generally best to leave this at its default value. In the developer options section, you'll find various settings. Most importantly, Draw Debug. This will help you visualize each stage of the push system, making it easier to understand or debug if you encounter unexpected issues. Now, in the push options section, enable check angle turn is a very useful setting. When enabled, it prevents the object from overlapping with other objects while rotating. Use check above. When enabled, the system checks if the player is standing on top of the object. If this condition is true, the player will not be able to push the actor while standing on it. Use actor fall. When this is enabled, the pushed object will follow the ground and fall naturally along slopes. If disabled, the object will not fall when pushed off an edge or down a slope. It is recommended to keep this enabled at all times. Can move forward, chalk, or backward. This toggles whether the player can push or pull the object in the forward or backward directions. Can move left, right. This controls whether the player can move the object sideways, left or right while pushing. Can turn left, right. This enables or disables the ability to rotate the object to the left or right while pushing. In the side push section, you can configure the object to be pushed only from specific directions. For example, if you want an object to be pushed only from the right side and not from the left, this feature is useful, especially when dealing with one-sided interactions like doors or specific mechanisms. These are all the important settings for the actor. Now, let's move on to the character settings. Let's now go over the various settings you can customize when using the AKO push system, starting with the core component options on your character. First, we have object types Ps, which determines the object type that can be pushed. Just make sure to assign the object channel called push. This is essential for proper detection. Next is push speed, which does refer to speed. It controls how fast the object will move while being pushed. Right after that is push range, rather the maximum distance the player can be from the object in order to initiate pushing. Now, if you enable use, turn in place, your character will stop walking when rotating the object, essentially performing an in-place turn to adjust the push direction. Very useful for tight spots or precise alignment. You'll also notice a setting called camera index. This is important if your character uses more than one camera. For example, if your pushing camera is the second one in your list, just set the index to 1, since indexing starts from 0. The same logic applies to the spring arm index, which lets you assign which spring arm to use during pushing. Then there's amount turn, which defines how fast the object rotates when you attempt to turn it, but that works hand in hand with the overlap count. This value affects how accurately the system checks for corners when rotating. A higher value means the system will check more frequently and respond faster, But if you go too high, it may trigger false positives, stopping rotation too early. So it's important to find a good balance between overlap count and amount turn for smooth and responsive behavior. Another setting worth noting is use check method 2, aim M2. When this is enabled, the character won't be able to push the object unless they're directly facing it. This is especially useful in more immersive or realistic gameplay setups and the first-person game. Following that, we have height of trace start M2, which controls the vertical starting point of the line trace used by method 2. It's particularly helpful in first-person games where the camera is positioned at eye level. Along with it is how far trace M2, which simply determines how far the line trace should reach. Now, on the audio side, enabling play sound stop push will play a sound whenever the player stops pushing the object. Similarly, play sound hit push plays a sound when the object collides with another surface while being pushed. Moving on to camera behavior, use limit. Camera. In turn, restricts the camera's rotation while the object is turning. The camera will still follow the player, but can only move vertically, up and down. This is ideal for first-person setups where full camera control might break immersion. However, if you want to activate this, make sure to also enable Use Limit Camera, which fully applies these camera restrictions. And again, only while pushing. If you leave it off, you'll stay in free camera mode. When Use Limit Camera is enabled, you'll then have access to values like max and min pitch, which define how far up and down the player can look, and max and min yaw, which limit how far left and right the player can turn the camera during pushing. Lastly, you'll find two more options that affect how the camera moves. Use camera rotation lag. In push, add smoothness to camera rotation while pushing. And use camera lag in push smooths out the camera's movement positionally. Both can add realism, but be careful. If not set up correctly, they may introduce jitter or tracking issues. It's usually best to leave them off unless you know how to tune them properly. In the end, if you have any questions, feel free to leave them in the comments or join the project's Discord channel. I'll be happy to answer all your questions there.